Welcome to the lesson, Air Supply. Bleed air is supplied from the main engines or APU. Air is bled from one engine. Bleed air temperature and pressure are controlled before supplying aircraft systems. The APU is only capable of supplying a limited air supply. Air supplies on each wing supply separate systems. Engine 1 and 2 supply the left side. Engines 3 and 4 supply the right side. A single engine on one side can support its own system. Each engine has a similar layout. Hot air is supplied from the final compressor stage of each engine and fed into the pylon. Within the pylon, there are a number of components to control the air supply and pressure, temperature, and mass flow. Air supply and pressure are controlled by an isolation and pressure reducing valve, normally called the engine air valve. Each valve is controlled by a two-position switch on the air supply panel. Press the Engine Air 1 button to control the valve. This valve controls the supply of air and reduces its pressure to 41 psi for system use. When the associated fire handle is pulled, the engine air valve will close. The engine air valve is pneumatically actuated and requires air pressure to open. If the valve is not in the position selected, an amber engine air valve annunciator will illuminate. Please press this button. If engine air 1, 2, or 3 are selected on, with the aircraft on the ground, a green air selected on ground annunciator will illuminate on the central status panel. There is no indication if engine air 4 is selected on. This allows engine air 4 to be used during takeoff if the APU is unserviceable. If the valve fails to control pressure correctly, an amber engine air fault annunciator will illuminate. In sequence, engine air valve 1 will illuminate as the valve will close automatically as a consequence of the engine air fault. The temperature of the air supply is controlled automatically. Cold air from the bypass duct is regulated by a temperature control valve and passed through an air-to-air heat exchanger called a pre-cooler. This reduces the bleed air temperature to 210 degrees Celsius. A mechanically operated duct pressure relief valve will vent any excess pressure into the pylon area. There is no indication of relief valve operation. In the event of a duct failure downstream of the pylon, maximum bleed airflow is controlled by a fixed venturi. A non-return valve, check valve, prevents air from the adjacent engine from entering the system. From each pylon, air is supplied rearwards for airframe systems. A separate supply controlled by an ice protection valve provides hot air for wing ice protection. A supply upstream of the engine air valve, number 2 and 3 pylons, only provides air for hydraulic tank and stall air pressurization. Air pressure is controlled to 50 psi by a regulating valve. The regulated air supply for hydraulic tank pressurization is provided by number 2 engine for the yellow reservoir and by number 3 engine for the green reservoir. Either or both engines, numbers 2 and 3, provide bleed air for the stall air reservoir. Blowout panels are fitted in the pylon to relieve excess pressure caused by duct failure or relief valve operation. Air is distributed from the pylons to the left and right systems. A connection between the left and right systems via a shuttle valve allows an air supply to the water tank and the forward and rear discharge valves. The air supply to the discharge valves is used to keep them open when the aircraft is on ground. Bleed air is supplied to 2 air conditioning packs at the rear of the aircraft to provide pressurization and air conditioning. Ice protection for each wing is supplied by one or both engines on that wing. Ice protection is supplied to the tail from both the left and right systems. The left system is used to provide air pressure for the flushing of the toilets. The APU can be used to supply air for air conditioning, toilet flush, water tank pressurization, and the discharge valves. The APU cannot supply air to the hydraulic tank or stall air reservoir. Airframe ice protection cannot be supplied by the APU, as it is unable to supply the volume of air required. When airframe ice protection is required, APU air must be selected off. APU air is controlled by a switch on the air supply panel. This switch controls the APU air valve. Please press this button. The air valve regulates the mass airflow to the air supply system to maintain a constant delivery pressure. If the APU air valve fails to close when the APU air is selected off, APU valve not shut will illuminate on the air supplies panel. Please press this button. Non-return valves, check valves, prevent engine bleed air from entering the APU. A leak of either non-return valve with APU air selected off will illuminate APU non-return valve leak on the APU panel. Check that all three blowout panels on each pylon have not operated and are secure. Before APU start, confirm that APU air is selected off and the APU valve not shut annunciator is out. After APU start, APU air may be selected between 2 and 5 minutes after APU power available illuminates. Air conditioning can now be used as required. Engine air must be checked off and the associated engine air valve and engine air fault annunciators extinguished. If the APU generator is used to provide electrical power for engine start, the air conditioning packs 1 and 2 and APU air must be selected off to reduce the load on the APU. After engine start, air conditioning may be set as required. Several factors must be considered before deciding the takeoff bleed configuration. It is always desirable to provide air conditioning for passenger comfort during takeoff. Unserviceability or company policy may dictate whether the APU is available or not. If the APU is available, takeoff will be performed with APU air switched on to provide control to the discharge valves and both packs selected on to provide air conditioning. Click on the air supply panel to set up the bleed configuration as shown in this example. If the APU is not available, we refer to the performance data to see if our desired takeoff weight is limited by having engine air selected on. If performance is limited, takeoff is performed with engine air 4 only selected on to provide control to the discharge valves. Click on the air supply panel to set up the bleed configuration as shown in this example.